Hi again and welcome back. Another day, another element. We're shooting down group 2, the alkaline earth metals that all have a similar property and they're reactive and they're all metals. And it's worth pausing at this point just to define what is a metal. Well, they're usually a sort of a lustrous, sort of silvery grey, with a slight hint of colour here and there for some of the elements. Usually solid at room temperature, with the exception of something like mercury. But you can hammer them out into sheets, you can stretch them into wires. Usually some are a bit brittle at room temperature again. But the most important thing about them is they are good conductors of heat. And if you look at this wire here, they're a good conductor of electricity. And all electricity is the flow of electrons, which are the particles which whiz around the outside, if you remember, along a cable. Now, this cable here, I've used this lightning bolt to sort of like demonstrate electricity going through, but the weird thing is, with electricity, I found this crazy when I found out, that it moves through a wire. Say if you had copper, for example, it moves through the wire at slower than the speed of a snail. And you think, how is that? If you flick a light switch on at the wall and electricity comes on, the light comes on straight away, you think that the electricity is almost instantaneous. Well, it is. But it's not the actual electrons which are instantaneous. And the best way to describe this, if you imagine a hose pipe full of water, 10 miles long, if I turn it on at one end, pretty much straight away, 10 miles away, water will start coming out. So that's how electricity works. The electrons are already in the cable, but they're free to move along. All you need is something to start shunting them along. Magnets are good at doing that. Anyway, so there's the basics of a metal, and except for hydrogen, all of these are metals, up to about sort of a weird step area here, and then it gets very strange in this corner here. Right, bring up calcium. Here's the card. Here's its atomic structure. Now it's number 20. So it's got 20 protons glued together by 20 neutrons with 20 electrons whizzing around. And it's reactive. Now, when you think of calcium, you think of maybe something white, because you think of milk or yogurt or bones and so on. But it's not. It's a silvery metal that's not found by itself. It's so reactive it can't exist by itself in the natural environment. It will usually latch onto something else. Now, it was discovered again by Humphrey Davy in 1808, and using a thing called electrolysis. No, that's not hair removal from his legs. It's a way of using electricity to pull the element out of a solution. And he did really well. He discovered quite a few elements. And he named it originally a calyx, which was an old Roman word for lime. Now, lime was used in all sorts of things. It was used to help stop pollution. It could be used to make cement. It had a lot of applications, but the Romans knew about it. So if you have a look at our map of the world and what makes up the elements, you can see there's a lot of calcium, but it's not found by itself. It likes to join on to other elements like carbon to make calcium carbonate, to magnesium to make dolomite. It will join onto sulfur to make a thing called gypsum. Gypsum is used in things like plaster, as in walls. Now, in the background as well, he's got some marble. If you can see the background there, because marble and chalk. And if you look at these beautiful pictures, our white cliffs just down the road, because I live in Eastbourne, that's all made from a calcium carbonate. basically the shells of billions of tiny prehistoric creatures. So for us, we need it as well. For, say, your bones. It's used in the electrical conductivity along your nerves and for your muscles. It can make your heartbeats change as well, depending on how much calcium is in your body. And there's loads of it in the oceans. It's one of the main things which help build coral reefs. Right, so calcium, pretty cool. It's a metal, reactive, and it makes up your bones along with magnesium and other things like phosphorus and hydrogen and oxygen. But you can say that a lot of your bones are metal, which makes you even cooler than this guy, the Wolverine, who has adamantium metal in his skeleton, which makes him indestructible. And he can also cure himself, heal himself really quickly, which is a good job. Can you imagine the damage that you could do with those claws? But the thing is, this is fictional. You really do have metal in your bones, and you're real. And that makes you cooler than him, and he's cool. So, thank you. See you next time for strontium. Take care. Keep safe.